Welcome back. In this lesson, we're diving into how machines understand images. While we as humans can instantly recognize objects, faces, and scenes in images, teaching computers to see is a fascinating challenge. Let's break down how computer vision works. At its core, a computer sees an image very differently than we do. While we see a cohesive picture, a computer sees a grid of numbers. Each point in this grid is called a pixel, containing values representing color and intensity. For a color image, we typically have three channels: red values, green values, and blue values. Here's what an image looks like to a computer. Now, before we can analyze an image, we need to prepare it. Think of this like getting ready for a photo. We need to make sure everything is standardized and clear. Common pre-processing steps include resizing images to a standard size, normalizing the pixel values, adjusting brightness and contrast, and finally, removing the noise in the image. Let's see how we can implement these pre-processing steps. Now comes the interesting part: teaching computers to understand what they're seeing. We do this by extracting features, which are like the distinctive characteristics of the image. Watch what happens when we extract different types of features. We have edge features, we have color features, texture features, and then finally shape features. Here's how we can extract these features. Now let's talk about object detection. This is how computers can identify and locate specific objects within an image. It works in several steps. You scan the image in the regions, you extract features from each region, classify what's in each region, and then finally draw bounding boxes around detected objects. Let's look at a practical example. When you take a photo with your smartphone's camera, face detection finds any faces, autofocus determines important areas, scene recognition adjusts the camera's settings, and then finally, image enhancement improves the final result. Here's a simple object detection implementation. Now let's try running object detection on some sample images. The amazing thing about these fundamentals is that they form the building blocks for more complex computer vision tasks like facial recognition, scene understanding, action recognition in videos, and visual question answering. Before we move on, let's try a hands-on exercise. Take a simple image, apply basic pre-processing, extract some features, and try detecting the objects. Understanding how computers process and analyze images is crucial for building multimodal systems. In our next lessons, we'll see how to combine these visual understanding with other modalities like text and audio.